Hello, I'm Mrs. Jacobson, and today we're going to graph logarithms and find the domain and range. So if we look at our problem, log base 2 x minus 1 minus 3. Now, the normal log before we start shifting is always at this point here, at 1 on the x-axis, and we have an asymptote here because it goes like this. Now, to know how it's shifting here, it's the base. Because when the base and this value are the same, your answer is 1. So it would be 2, 1. So this is the graph that we're shifting. And this is an asymptote. Now this is going to move right 1 and down 3. Vertical asymptote moves when you go this way. And we're moving right 1. So the vertical is at x equals 1. So this point is going to move right 1 and down 1, 2, 3, and it's going to be here. And this is going to move right 1 and down 1, 2, 3, and it's here. And then my asymptote is moving over 1, so it is here at x equals 1. And then here's my graph. Domain, we don't have any values until we reach 1, and it's 1 to infinity. The range is all real numbers because it's doing all of these, and then this is slowly going up, but it's going to keep going up. So it's all real numbers. Let's try another one. So this one's a negative log. I'm rewriting it. A negative log base 3 of x. So we're not shifting at all. This negative's just flipping it. So our first point is always here at 0, 1. And the next one, this is 3. So it's 1, 2, 3, and up 1. So this is my graph before shifting or flipping. Now since my asymptote is at 0, it's going to stay there. Because we're not moving right or left. The only thing we are doing is flipping on the x-axis. So this will stay here, but then instead of being here, it flips and it's here. So then the graph goes like that. So then the domain, there's no values until I reach 0. So 0 to infinity. And the range is all real numbers because this is going to keep going down and this keeps going up. Negative infinity to infinity. Let's try another one. That's x minus 1. Okay, so we start here. It will always go at that point. And then we're going to use one more point, which is 2, 1. 2, 1. So it's whatever the base is. If the base was 5, we go over 5 and up 1. So this is our basic graph. It has an asymptote at 0. but we're moving right 1. So the vertical asymptote will be at x equals 1. So we will have an asymptote here. And then this is going to move right 1. This will move right 1. And our line will be there. Domain 1 to infinity, because we're starting here at 1 and going over. Range, all real numbers, because this keeps going down and that keeps going up. That's it for the graphs. The other one we did not cover yet in this section was expanding logarithms. Right here. Let's see. Expanding logarithms uses a lot of your rules. And you want to rewrite these so that there is no exponents, fractions, or products within here. Okay, so when you have a division, anything in the bottom becomes a minus. So it's log y to the 5th minus log z. And then exponents come down in front. 5 log y minus log z. That's all that's to it. Try another one. That's almost exactly the same. Log y to the 7th over x. The top one's positive, y to the 7th, minus the bottom one. And then we can't have exponents, so we put them in front. And that's all that's to it. See if we can find a better one. Okay, there's one different. Log y z to the 9th. Now these are multiplied, so they become an addition. We have log y plus log z to the 9th, and then bring your exponent down in front. That's all that's to those. Let's see if there's any other that are like put all three together. Maybe not. Looks like they're all the same. Okay, let's do one a little bit harder. If we have log x to the 5th y z cubed, and we're breaking that up. No, let's put a, no, I'm going to do it. All right, log x to the 5th. This is on top also, so it's a plus. And this is on the bottom, minus. And then bring your values down. So it's 5 log x plus log y minus 3 log z. Now the other one, and I know it'll be on the test, is a square root. When you have a square root, it can be written to the 1/2, and then you can bring it out front. So any radicals have to be rewritten first, and then you just use your same rules. That's everything.